Hello, everybody. Okay, so we have finished chapter number 3 now, and I have also posted the homework for the same. I mean the tutorial problems. Okay, so we will discuss today about this chapter. So if you have any doubt, let me know. Any doubt?
Sir, I have one doubt in the Moodle quiz that we had.
Okay. So Moodle quiz, I already posted the solution.
Yes, sir, I saw that.
Mhm. So you are not happy with that?
Sir, actually, some questions. We were calculating the value of omega, and
Hmm.
we needed to calculating rad per second. But as means if we directly substitute the units as in question, then we were getting the frequency value per second. Then
Okay,
should we
you
convert it
send me.
to that
Okay,
rad per
okay. So let's utilize this for chapter 3. Okay, we don't want to go back to chapter 2. Okay, so you can send
Okay,
me an
okay,
email.
sir.
Okay, you send me an email regarding that question. I will explain through the email. Okay.
Sure, sir, sure.
So you write your doubt. Okay. So today we will discuss chapter 3 because I'm going to again set a homework now. Okay. So by tomorrow it will be out. Okay. So that's why. So let's focus on chapter 3. Okay. So lecture number 5 to 9. So any question on chapter number 3? No? No questions? Okay. Okay, so as I said earlier, today onward, I will also record your attendance. Okay, and I will take some decision later on based on that. Although attendance, as per the senior tooling, 75% attendance is required just because of online, things right now, this has been relaxed. But doesn't mean that if you have a facility to you know like attend these live sessions, if you don't attend, then really means that uh, I think we will have to do something about it. Yeah. Those who have not access, I can understand, they can take permission, but those who have access, they should attend. So although I have not informed, but I will take some decision. Okay. So I being the Associate Dean of UZ, I also want to discuss this in SUG's meeting as well. So that's why I suggest you be here always. Okay. Otherwise, later on, I don't know. There may be some decision based on this one. Okay. So you may have to pre-escalate. Say, for example, if you are not able to, if somebody not able to attend, can take permission or something like that, but something is going to come, that I can tell. Okay, so always attend these classes, actively participate. You have any doubt, just let me know. Okay, so let me start with if you have any doubt, let me know right now, else I'm going to start tutorial problem. So you start with 3.3. Okay, so we will start with 3 3, and it says a weight is attached to a spring of a stiffness. So K is given. K is equal to 525 Newton per meter. Has a viscous damping device. When a weight is displaced and released, so we have this kind of situation. So we have K here, C, M. Okay, and K is given 525 Newton per meter. Okay, and then it says if you displace this one and release, then period of vibration is found to be 1.8. Okay, so if you displace and release, that really means this is damper, so it's a damped oscillation. So basically what we have is TD, right? So TD is 1.8 second, and ratio of consecutive amplitude is 4.2 to 1. So x1 over x2 is equal to 4.2 divided by 1, that is 4.2. Yeah. So this is given like this. Yeah. Okay. Now we have to find out what is the value of something else you have to find out based on. Now it says, given this, given what? Given a spring constant, which is like this one, then if you displace this one and release, then you find out the period of oscillation is this much. And also, since this is a damped oscillation, this will be going like this, right? So it will start with a big one, then it will go and die out. So amplitude of two consecutive, like from here to here, ratio is 4.2. So what will give this together is going to give us omega n and zeta. Yeah. Okay. So we will get omega n and zeta from here. Now, then it says that determine the amplitude and a phase when a force of. So if now you'll apply a force F is equal to 2 cos 3t. So it says amplitude and phase. What is the amplitude and phase? So that means what is the value of x naught? Yeah, x naught equal to what? And phase phi equal to what? Okay. So basically we have this system, and the stiffness is given, C is there, but we don't know the value, so we have to find out C. And M is also given, but we have to find out M. But only if it's required, otherwise we don't do it. Yeah, so that's the idea. So how do we find out? So first from we will use these two to find out omega n, zeta, and omega n, you know that omega d we can find out. Omega d is equal to 2 pi over t d. Yeah, and this is omega d, right? And which is equal to, you get 2 pi over 1.8, right? Okay, so this is what you get. But omega d is also, you know, nothing but this is omega n multiplied by 1 minus zeta squared. This is what omega d is. So you can find out omega d is known. That means omega n minus this is equal to this. So we get one value from here. We can say that omega n multiplied by 1 minus zeta square equal to 2 pi over 1.8. So we get one equation from here. So, but second equation, this one will exactly tell us what zeta is. So once we know zeta, we can find out omega n from here. So let's say this is equation number 1. Then we go and since just a delta is what? Delta is ln x1 over x2. This is logarithmic decrement, right? Is given by, and you know that this is 2 pi zeta over root under 1 minus zeta square. Yeah. Okay. And hence x1 over x2 is nothing but e to the power this 2 pi zeta over root 1 minus zeta square. That's what it is. And hence this is given to 4.2. This is what it is given to be 4.2. This is here 4.2. Okay. So now we have another equation. This one is given, and hence you can 2 pi zeta over 1 minus zeta square is equal to ln 4.2. Right? So we get another equation, this one, and this will tell you what is zeta value. And once we know this zeta, this equation number 2, the equation number 1 is here. Okay? So from equation number 2, we got the zeta value, and then we put zeta value here, we get omega n. So from 1 and 2, we can find out omega and zeta both, right? So it's clear now, omega and zeta. Now, question you have to solve here is, if force, you have this force, then what is the value of amplitude and what is the value of phase? Now, looking at the equation, if you have this equation, what equation you have? You have mx double dot plus cx dot plus kx equal to f naught sine omega t, right? So this is or in this case you have f naught cos, so it doesn't matter, it's the same thing. So we have here, we have 2 cos 3t, right? So you have f naught cos omega naught t. Yeah. So okay. So we have f naught cos omega t. Yeah. Okay. Now, if you have like this one, then we know that you can find out the amplitude. And how do you find out? So if you see the video lecture, you will find out that amplitude is nothing but x naught over f naught divided by what? Then you get k minus m omega square plus c square omega square, right? Root under of that. Yeah. So this is what x you get in this case. Now you can divide it by k. Yeah. So divide by k on. So what do you get? So we get is equal to. We can do like this. K. So why we are doing it? Because we have zeta and omega n now. So we don't have k and m. So we can, by dividing by k, we can get rid of k and m, and we will get omega and zeta terms. Okay, so we have f naught over k is there. So k is known, right? So c we don't have, m we don't have, k we have, k is given. So f naught over k and divided by root. Yeah. And then we get what? We get here 1 minus omega square over omega n square plus. Yeah. Plus, and we have here c square omega square over k square. Okay, so c omega over k square. So this we can see Yeah, if you have C over K, then what do you get? C over K is equal to, again, all those things you have done already. So let's divide by C over 2 root Km. Here also divide by K over 2 root Km, right? And this one you call it, this one is zeta. Yeah, so we have zeta here. Yeah, okay, and divided by, and then we have here we have, so we can have half that we have, and then we have root K over M. That's what we get. So again, working out here, but you can, like you can also have the formula written directly. We could have done that, but still I'm working out in front of you so that you see that what we get here is 2 zeta over, and we have, we have M over, so K over M, correct this. So we have K over M, 2 zeta over omega. Right? This is omega, not omega, it's omega n. Yeah. So C over K is 2 zeta over omega n. And hence we can write it, our x value, if you look at this one, this is x naught value. Yeah, so this is x naught value. And we get x naught is equal to, x naught equal to f naught over k divided by root 1 minus omega over omega n square, right? So plus C over K is plus, and C over K square. So we have here 2 zeta omega n square over omega square, right? So we get that, and hence now you see everything we have in form of now f naught, which is known now. So f naught, so we have f naught cos omega t. So f naught is given, if you look at the given problem, f naught is 2, this is omega, which is 3. So all these values are given, omega n and omega and zeta we have found out, and hence you can find out x naught now. So everything is known now. F naught is known, k is known, omega is known, omega n we have found out, zeta we have found out. So all the things find out, we have find out the x naught. Right? Now, similarly, now the second thing we have to find out the phi, right? And phi is, how do you find out? So we find out phi from, if you look at the video lectures, then we have C omega. So the phi is given by tan inverse and C omega over we have k minus m omega square. Yeah, so this is what is phi is. Yeah, so now, here also you can divide by k, and what we can get is tan inverse, and c over k is this one. So we get tan inverse 2 zeta omega over omega n divided by 1 minus omega square over, right, omega n square. Yeah. So this is how we can find out. Yeah, so we also did here derivation. We did not just actually we did not just solve the problem, but also we have done derivation accordingly so that we don't have any confusion. Yeah. So as such, this whole chapter is uh, easy because what you have to do is you have to just read the problem and convert that into a problem which has a spin mass damper. That's it, and from there you can find out. So any question, guys? Any problem here? Okay. Let's look at 3.7 now. Okay. Okay. 3.7. So let's read it. 3.7 is we have a problem which looks like this. So we have like this. So we have x1, this is x2, and x2 is given to be x big X2 sine omega t. Yeah. Okay. So for this system, we have to find out equation of motion and solve the steady state amplitude and phase angle by using complex algebra. Okay, so we have to use specifically the complex algebra, and we have to find out x1 0 because amplitude of this one and phase angle. Yeah, so and the phase y, the phi. Yeah. Okay, so how will you do it? Okay. First, we have to derive the equation. Once you derive the equation, rest becomes very easy. Yeah, and how do you do? The first we have to write down the on a free body diagram. You always start with free body diagram. So we have C here, M here, we have K here. So write K here, and free body diagram. So let's you are moving mass by x1 amount. Then what it will do? This damper is going to resist movement of mass, right? So, and what will be the resistance? Will be Cx1 dot. So basically, we have this mass m, and then we have the in the opposite direction. What you will get? Cx1 dot. Yeah. So we got that. So this will move. When this moves, there will be a velocity x1 dot, and the resistance will be cx1 dots, which will be opposite to the movement. So either moving this side or velocity this side, the force will be backward. Now here also we have x2. This is also moving. So again, good thing is you can assume that some quantity is bigger than the other quantity. So in lecture also we have done like this. So assume that x2 is greater than x1. Then what it will do? If this is bigger than this, then there will be a stretch. Right? So then if x2 is more than x1, then this will be under tension, and because of that, what will happen? Because of the tension, this will try to, if this is bigger than this one, this will pull this way. Yeah, so there will be a net force acting on this one, and that force will be what? That force will be K times, right? Will be K x2 minus x1. That will be the force. Yeah. Okay. So because x2 we assume to be greater than x1, and hence there will be a stretching of this one. If this is a stretching, then what happens? This is going to pull x2 minus x1 will result into the stretching of a spring, and because of that, the spring force will try to pull in this way. A value will be k times k2 minus x1. Now net, there will be the equation of motion of f in x direction has equal to 0, right? And not equal to 0, but m in this case will be mx1, right? mx1 double dot. So, and what do we see? We see force. If you look at this, we have minus cx1 dot plus k x2 minus x1 is equal to mx1 double dot. And what do we get finally? We get mx1 double dot plus cx1 dot plus kx1, right, is equal to kx2. So this is the equation, right? Only this is the equation you get. So this is the equation you get. Okay. Now we have to solve it, where x2 is given as big X2 sine omega t. So we have this. So basically, let's write it again. So we get mx1 double dot plus cx1 dot plus kx1 is equal to kx2, right? Which is equal to kx2 sine omega t. So this is the equation we get. Now we have to solve it, right? We have to solve using what? Using the complex method. Yeah. So complex method, how do you do that? So if you watch so we can write it here, f naught sine omega t. So video lecture, if you see there, complex method has been studied there. So how do you do that? We assume x, in this case, f naught sine omega t, which is basically is the real part, imaginary part of what? F naught e I omega t, right? So this is what it is, right? Okay, and hence we can solve. We can assume x1 is equal to. So we can assume in this case x1 is equal to x naught e I omega t, right? Okay, and then if that is the solution, then if we put it here, then automatically we will get. So here x naught may be complex number. Yeah, so we will see that. So we can put it here. So we get x1. So in general, we can solve for this. Solve for what? Solve for this. mx1 double dot plus c x1 dot plus kx1 is equal to f naught e I omega t. So we solve for this one, and accordingly we can, if we have this side, after that we can actually look at the imaginary part or real part. Accordingly, we can find out what is the solution for sine and what is the solution for cos, right? So if given this equation, if we can solve this one, we can solve this. Yeah. So let's look at this one. If the solution, if the equation is if you have to solve this one, then what is the solution? solution will be something like this one. And we put it here. And what do you get? We get this. X1 double dot, so we put M, then we get minus omega square, right? And then we get X naught, we get EI omega t plus C, right? And then we get the X1 dot, so we get I omega X naught EI omega t plus X naught EI omega t, right? And will be equal to F naught EI omega t. So we have this equation, right? This has been done already in lectures actually, so it is not new. And we can now get rid of these values here. So we had, which all things we have? We have EI omega t both the sides. We can get rid of that. So what we get? We get minus M omega square and X naught minus M omega square minus M omega square X naught I C omega X naught plus I C omega X naught, right? Okay, and plus K X naught is equal to F naught. Yeah. So this is what we get. And okay, now here F naught. So if we have to find out the X naught, then how will you find out? So we can find out X naught equal to so basically here we have X, this one will be equal to F naught over, okay, so let me first okay, so we have X naught here, and then what do we have? We have multiplied by, and we have minus, we can combine now this one and this one and this one, we can combine. So we have K minus M omega square plus I C omega, right? X naught is equal to F naught. Yeah. Okay, and then how do you find out? So X naught is equal to F naught divided by K minus M omega square plus I C omega. Okay, so what do you find? You find X naught is basically is not a real number, right? So this is the X naught itself is a complex number. Why complex number? Because you assumed F naught is a real. We started with F equal to F naught e to I omega t. We started with F naught as a real, and we have a real divided by a complex number. So that means X naught itself is not a real number. It has to be complex. And hence we write this F naught, the X, this we can write it as X naught, amplitude of that, and then e to the power I phi. We can write like that, right? Okay. Now we have to find out this. When you say amplitude is X. The amplitude is X naught, right? So this is the amplitude. Amplitude becomes equal to is F naught divided by and root under K minus M omega square A square plus C A square omega square. So of course the amplitude will be, take amplitude of that will be F naught divided by, we have to take a square root, and this becomes a square and this becomes a square. That's what we did like this one. Yeah. Okay. And then what will be the phi? So phi we can have, right, you know, so if we have if the whole thing, So x1, this x, we can write it as x naught e to the power I phi. Then accordingly we can find out what is the value of phi, right? So how do you do that? So basically we can look at here. So x naught we are writing like this one. Now we have to write in a complex notation. Yeah. So how will you write? So x naught is equal to f naught, and then you have divided by root under yeah, sorry, not root under uh, k minus m omega square plus I c omega. So this is the x naught, yeah, and which is equal to f naught k minus m omega square minus I c omega divided by k minus m omega square plus c square omega square, right? So what you see, the is now real number here, and this is the real part, this is the imaginary part, right? So x naught is and we said x naught to be given by x naught e to the power I phi, right? And from here you can see that so basically the e to the power, so you can expand that equal to x bar, and then we have cos phi plus I sin phi, right? So you can readily recognize that phi you will get as uh, minus c omega tan. So tan phi will be minus c omega divided by k minus m square. So you will get phi equal to tan inverse minus c omega divided by k minus m omega square. Yeah, so automatically we'll get that. So we know that this is a phase lag there, hence because of this minus we get minus, yes, phase lag. So yeah, you can find out like this one. Yeah, so we have solved, actually this is the in lecture only we have covered all those things, but still I solved in front of you. Okay, so any question, guys? Any questions so far? After 3.7 we have 3.9. Any question? Okay. Okay, guys, so I request you to study, so online mode doesn't mean that you don't study. Yeah, so you are not asking questions really means that you are not watching the videos probably, or not solving problems. Yeah. So last year, for example, I had a lot of questions during the live sessions. You can also see, if you see last year's live sessions are also there, recorded version there on the YouTube. You could see how many questions I used to get. Yeah. So anyway, 3.9. So this question has a counter rotating except eccentric mass. So this we have like this. K over 2, K over 2, C. Okay. And counter rotating mass, so we have here and here. Okay, and this is going like this one, and this goes like this one. Okay, so basically this is like this. So we have counter rotating mass like this, and yet position. This arrangement is so that the forces cancel out. So this is a eccentric mass which is rotating, and they are in sync, so that if this is at top, this also is top, and such that the lateral forces are balanced, only the vertical forces remain unbalanced. So that's the idea. So because of this rotating mass, there will be a force created, and because of that, this will act as a force applied to the mass, basically. Yeah. So this will be the F coming to the system. So now, what is the problem? The problem given is such like this. So we have this where M is given to be 181.4 kg, and at a speed of omega. Okay, so at a speed of 900 rpm, so omega equal to 900 rpm, and which is equal to 900 and per minute, so divided by 60, that is 15 hertz. Is the 15 hertz so basically let's call this one is 2 pi f, basically. So divided by pi, I will just write divided by pi. Okay, so omega equal to 2 pi with 900 rpm equal to 900 by 60, 15 hertz, basically. Yeah. Okay, so omega will be 2 pi multiplied by 15. Okay, now then what it says? It says that at this RPM, okay, this RPM, the stroboscope shows the eccentric mass to be at the top of at the instant the structure is moving upward through the static equilibrium position. So see the static equilibrium position, let us say it is here, like this one. It says when this mass is right here at the equilibrium position, is right here, and when it is moving up, this is moving up, then this rotating mass is at the top. So this mass is at the top when this mass is at the equilibrium position and which is going up. Now, when this mass is here and it's at the equilibrium position, it's going up, that really means the phase is zero. Right? For this will be phase, basically, right? So this the phase is zero. That really means, yeah. So that really means that it's let's say you can write the phase. So we can write here. So phase for this is zero. Yeah. Okay. And now, and at this time, this rotating mass is at the top. Okay, so if rotating mass is at the top, then what does it mean? Then we can write, because of that, we have force. Force we can write F is equal to F naught sine omega t. We can write like that. Yeah. Okay, but typically how do we write? We write like we know that there is a we write the equation. What equation? We have this kind: mx double dot plus cx dot plus kx equal to f naught sine omega t, and then we have x. We have x which solves, and the value will be x naught sine omega t minus. So that really means there is a phase lag of phi. Means if f is omega t, x naught is omega t minus phi. Right? Okay, so in that respect, we have to see what is the phase difference between this and this. phase of x. This signify phase of x. So this one is relating to, so this one is relating to this guy, x guy, right? For f we have this one. Looking at this one, so let's okay. So if you see, if there is a eccentric mass, this distance is this e, and the mass small m is like this one, and if it is rotating, let us say it's rotating with omega, right? This with omega, then what happens? There will be a centripetal force which will push the which will pull this mass away from the center, and what will be that force? That force will be F equal to m omega square e. That is the force. Now there are two of them. So in the picture we have one here and one here, and both are synchronized. So what will happen? We have another here, we have m omega square e, we have another, this is m omega square e, right? And finally we will have, so our reference will be from here. So let us say we have the theta here. So finally the horizontal components will be cancelled. Yeah. So what we will see here? We will see here the component of that. So for example, here one component is this one. So this component will be m omega square e cos theta, will cancel out, right? This is m omega square e cos theta. So this is also theta, and then we have m omega square e, and then we have sine theta, right? So this also m omega square e sine theta. So what we see, total force will be vertical one only, right? So total F is given by m omega square e sine theta, twice, two of them. So one coming from here, one coming from there. So they will combine together. So what we get is 2m e omega square, and we are taking theta from here, so we can take theta is equal to omega t, right? So we get here sine omega t, right? So this is what the F is. So this is F equal to F naught. This is F naught sine omega t, where F naught is equal to 2me omega square. Yeah, and this me is given me. So this is the value of the unbalance of each wheel of the exciter is 0.0921 kg meter is given, is equal to 2 multiplied by 0.091 kg meter multiplied by omega, and omega we have 2 pi n, right? So 2 pi times 15, right? So omega square. So this F naught is given. We know the F naught. Yeah. Omega we know already. Yeah. So this is known. Okay. But only thing is we have to look at the phase difference. Okay. So now coming back to the question. So this is to put some background so that we can relate. Now coming back to the question, we have this mass which is right at the equilibrium position, and what are we doing? This is just going upward, right? So this is at equilibrium position and it is going upward, and at the same time the rotating mass is at the top, is the topmost position, right? So the rotating mass is at top position, and this top position is so here sorry, this is capital M, take capital M. So, and this is here and this is here. This is the rotating mass. This is rotating like this. So let's make it like this, and like this. So this is the top. So this one is at the. So this is at the top position. Top position means what? Omega t is equal to. Top position means theta equal to. So we measured the force is upward. Our theta started from here. So theta equal to pi over 2. That is omega t has, so is equal to 2 pi n plus pi over 2. That's what it means. Okay. So that really means we have seen that the phase for this one is phi equal to 0 because it is right here, which is going upward. But phi for this one, the force, phi for force is equal to pi over 2. Phi for x is 0. Phi for the force is pi over 2. Right? Now, in the equation, wherever in right, let us say this is a capital M. So m x double dot plus cx dot plus kx equal to f naught sine omega t. Our x is given by x naught sine omega t minus phi. So x will always lag behind phi. Right? So here also it's lagging behind phi. So the force phase is pi over 2, then the displacement phase is 0. Right? So if you want to find out the phi, how will you find out? That will be the phase lag in this case, phase lag will be pi over 2, right? So this is leading, right? This is pi over 2, this is 0. So phase lag of x is pi over 2, right? Yeah. Okay, so for example, in this case, look at this one. Phi of f is 0, right? And phi of this is minus phi. So 0 minus phi is phi. You get the phi. Yeah. So similarly, your phase lag is pi over 2 simply. Means this one is leading and this is lagging. So phase lag of x is pi over 2. And you know that when phase lag is pi over 2, meaning what? That really means the omega. That really means omega is equal to omega n. That really means. Why? Because in this equation, the phi, you know that tan phi is given by c omega over k minus m omega square, right? And hence, if phi is pi over 2, then k has to be equal to m omega square, right? So if phi is equal to pi over 2, then k minus m omega square is equal to 0, and hence omega square is equal to k over m is equal to omega n square. So omega, that will happen when omega means the forcing frequency matches the natural frequency, then that will happen. Yeah. So the question is, what is the natural frequency? The value will be natural frequency will be, or is omega n will be equal to omega itself. And we know that omega is what? Omega is 15 hertz, or 2 pi times 15 radian per second. You can write in that, or this becomes 30 pi radian per second is the answer. Very easy. Answer is trivial. Answer is like omega is equal to omega n, and hence whatever the frequency or RPM of the rotating balance, the unbalanced mass is, the same should be the natural frequency, because in that only the phase difference or phase lag will be pi over 2, and hence that's the answer. But in order to understand that, we have to understand things. So it's not just by the equation, you should also understand, you should have some insight, and hence I try to explain that way. Okay, so one part is of this is done. Now natural frequency of the structure, damping factor of the structure, and the amplitude and other things are accordingly you have to find out. So once you have found out omega n, then you can find out other things. Yeah. So which all other things we can find out? So some other data is given, and one data is the amplitude. Okay, so what is given here is x naught is given. If x naught is given and omega n is given now, see, you have the omega n now, and you have x naught now, so you can find out zeta very easily, right? So you know that x naught phi is given already, so we can find out from there. Yeah, so x naught is equal to, we already know this will be f over k divided by root 1 minus omega square over omega n square plus 2 zeta omega over omega n square, right? Okay, out of which we have the value given for okay. So which all things we have? We have value of mass. So value of mass is given already. So now omega n is given. So then what is remaining? So omega n is equal to k over m, and where mass is given. So k over m is given, which is equal to 181.4 kg. So from there you can find out k, right? So we have k value, can find out. So k value is known. F naught, this is f naught. F naught is also known. This is m omega square e, right? So this is also known. Now omega and omega n is known. So basically this both becomes equal to 1. So value is basically x naught is nothing but f naught over k divided by 2 zeta omega over omega n. Why? Because at the resonance, basically this value omega is equal to omega n, that we have seen already. So this term will not be there. So only this term, which is a square, so a square root of that, so becomes this. So from here x naught is given, and f naught is given, k is given, omega is omega n, so this becomes f naught over k divided by 2 zeta. That's it. Yeah, so what do you get? You get trivial answer. So you very easy answer. So we get zeta is equal to f naught over 2 k zeta and x naught. Yeah. So x naught is equal to this. So hence zeta, it goes here. Zeta is equal to f naught over k multiplied by 2, right? So it is not 2k x naught. Okay. So this term will not be there. Yeah. So let me write finally here. So we simply get, let me write here, we get zeta is equal to f naught over 2k x naught. Yeah. Any question, guys? That is all. Any question? Okay. So I'm going to post the homework number 2. Okay, and that will be due uh, sometime soon, probably on Monday or something. So I will give you 2-3 days. I mean, no, Monday, no, I think maybe on Sunday only. Okay, so I will see. So I will give by tomorrow. Okay, and then after that, there will be quiz. So quiz I will announce, but it will be very soon. Okay, so within, I think after a week, probably. Yeah, so I will see. I will announce. Okay. Okay, any questions? Okay, guys, that is all. Okay, bye.
Thank you, sir.